Hi guys, I was looking at these Christmas lights. I have more of these and I have some more sets I want to do something really interesting with an Arduino project I built some years ago, see if it still works. But these ones, blue and white ones, I had them in the office yesterday. I thought there was a few LEDs out and I plugged them in and they were working basically. Just a few blue LEDs look like they need changing. I found one broken connection. So while I was doing that, I decided to just switch them into the mode, you know, where they just on steady. It's just easier to figure out the ones that are not lit up. So I was doing that. There's a button on this thing, yeah. And I pressed the button several times and now only the white ones work. The button still selects different settings, but only the white ones are working. And since then, the blue ones don't work anymore. So I thought, well, I doubt like something's gone wrong so that like all the blue LEDs have gone, because they're like in sets of 8. Yeah, there's so many sets of 8 in here. So I think something might have happened to the controller. This thing. The thing's rather worn off. I mean, I've had these for years. They've been fixed numerous times in the past, yeah. So what can we see? Well, it looks like 0.12 amps. Yeah, that's on the mains, I think. 31 volt, I think it says. 31 volt, yeah. So there's like a little switch mode power supply. I mean, one of the things I thought was maybe that the plug is just not making contact. So we have 3 wires in here, so it's 3 pins. There'll be one common and then the other 2 control the 2 strings of LEDs. So make sure that's plugged in. What happens? The same, so it's not just that. So the question is, has something gone wrong with this, and why would it go wrong while we're just pressing the button? Let's see. So the first thing I think we need to figure out is what's going on here. Yeah, I don't know which is the common. I don't know which are the 2 channels, to be honest. I'm sure I could work that out. So this is the start of the string. Now we can see that we have 1 wire coming in here to this LED and 2 going out. So one of the 2 going out will go to the next LED on that chain, which is this one. You can see the pins. Oh my gosh, there's something living in there. We have some wildlife. No, I don't think it is living in there. It's just something stuck on the wire, yeah. Oh, like a little thread, yeah. Look like something was running around for a minute. No. So anyway, having just dealt with the not wildlife, we have 1 coming in and we have 2 going out. So one of the 2 will go to the next LED in that chain, and the other one will go to the first of the next set of 8 in that chain, okay? And then this one is the other channel coming in from the wire, okay, and the same thing applies basically. So yeah, it looked a bit odd, but yeah, so there we are. So that's the 1 coming in and the 2 going out, and then we have another one coming into this LED and 2 going out. Okay, you see there's extra wires on this one, so one of the extra ones will go directly. That'll be like the common one which goes everywhere. I think if we take this off here, we'll figure this out. Yeah, I figured it now. I took a bit more of the plastic off. So we can see we have 3 wires coming in. 1 goes to this LED and then 2 going out. Then the other 2, 1 of them goes to this LED and then 2 going out. And the other one is just here, so it doesn't actually attach to anywhere. So that is the return. That's the common wire. Now the common wire must be okay because the white chain is working. So the common must be okay. There's some problem to do with the channel coming in on here by the looks of it. So let's take this bit of tape off here. Yeah, so this is the channel coming in, and then this is going out to the next in the sequence and also going out to the first one in the next set of 8 on this chain. So we can have a look now with the multimeter. Let's see if we can see what's happening with this. Okay, so this common point here, this is where I'm going to connect my black meter probe. Okay, I'll just put a crocodile clip on, it's easy, leaves me a hand free. So that is the common or return. I just had a quick look. It appears that the common on this is actually the positive. So we have a plus supply coming in, and then it's switching the negative end to switch on the LEDs. So if we put the power on, you can see this one is on. If we go to the LED, you can see the voltage on it, yeah, 1540. So as the LED goes brighter, the voltage comes up. Full brightness about 25, 26, 27. Then as it dims, the voltage goes down again. Yeah, you can see that dropping down again. So on the channel that isn't working, that's this one. Well, we can see there's practically nothing there, okay. 0.3 of a volt, 0.5. So there's obviously a problem with the controller on this channel. It's giving very little voltage out. Yeah, you can see it. Yeah, that's the power coming in. I've never looked at one of these things before, but first time for everything, yeah. It's obviously a switch mode power supply with some sort of pulse width modulator that's driving each channel. I would hope we can fix this. Let's have a look. So we can see there appears to be glue along here, so I think that's where it's sealed. This end I think is just a ridge, so I think this piece is actually part of the top. It's glued inside here. So we could use the Dremel to cut this open if we have to, but I think most likely if we take a flat blade screwdriver, stick it in one corner and hit it with a hammer, it'll probably split open without damaging it very much. Yeah. I can see now it is 31 volt. I think it's 6 watts, 0 to 6 watts. Yeah. So in here, I think we're going to find there's a switch mode power supply and then some sort of pulse width modulation controller that's actually controlling flashing and dimming and brightening the LEDs. So let's see if we can get into it. It does say risk of electric shock, but considering this is actually working, so when we switch off, the LEDs stay on for an instant, they drain the power. So I don't believe there'll be any voltage in the capacitors in here. We will find out, no doubt. I also would say that the low voltage is here, so the high voltage capacitors are going to be that end of it. At least that's how I would have designed it. But I won't hold the metal work of the screwdriver, I'll hold the insulated part. Let's see. Well, nothing much happened. Let's go again. Yeah, this one's proving not easy to get into. Try it once more. Quite often they will just split open if you do this. Okay, so the thing is just jumping around. So what I think I'll do is I'll actually take the Dremel to make a little bit of a gap and then see if I can actually prise this open. I'm convinced the seal is here. Yeah, I'm still convinced that's where the seal actually is. Okay. Let's see. Yeah. So I was right about where the actual joint is. It is here. This is tough, this one is. Okay, we're in. So what do we have? Anything we can fix in here? Let's have a look. Well, these are the high voltage capacitors. Yeah. There we go. So we can double check, not with a finger, just use the multimeter, eh? It was about 8 volts. 8 volts. So there is a little bit of voltage in it, but nothing nasty. Okay, so yeah. Here we go. So these must be the output devices. We have 2 of them, okay? This is the return, the black wire, I'm guessing. What's that? 4.7k. I thought it might be a current limiter, which is not. It's too big a value. This will be the chip that's controlling this. No, this is the EEPROM 24C02. That contains the sequence for the controller. This must be the microcontroller on here, under this blob here, glop top or whatever they call the thing. That's your microcontroller. That's the EEPROM. I bet you could read that out, you know, actually. That'd be interesting. Even if it's, yeah, I'm sure you could read that with my EEPROM program. It might be interesting to do that, actually. So these are 2 output devices. We can see the 2 wires going here. Yeah, the return comes back to here. So this is your large, let's say large smoothing capacitor. Positive end, yeah, I did say it was switch. It was a common on the positive, and then it switches via these 2 to ground effectively. So your ground, well, I think is here. That's the negative end of the capacitor. So you'd think, yeah, and then these are the 2 returns which go to these 2 devices here. Yeah. This will be the gate or the base, depending on what these are, and then the other end will go to the ground here. Pretty sure we can just check that. Okay, so resistance range. So negative end of the large capacitor should go, you would think, to here. Put it onto continuity. Yeah, and the other one also. Yeah, goes to both of those. Okay. Not sure what that thing is. See there. Oh, I know exactly what it is. This is where the button is. So you press the button, it just contacts across here and sends a signal into here to tell it to switch to the other or the next pattern, the sequence. Yeah, that's exactly what that is. Okay, so let's check these two devices and then let's see if they both get in drive effectively. So I'm now on diode mode. So this is the gate or the base. That reads open. This will have a resistance across it. That reads short. That doesn't read short. So it looks like this one is dead. Let's go again. Yeah, it looks like that one is dead. Is this a MOSFET or a transistor? What do you think? I think it's probably a MOSFET. Yeah, parasitic diode with the negative towards the drain, I'm pretty sure that is. Oh no, it actually reads like a transistor. Look. Yeah, it reads like a transistor. Yeah, so that must be a transistor. And this one is short base emitter. Quite clearly. 6CC. What's that thing? Let's have a look. Was it 6CG? I've just used Google then for SMD code. 6CC SOT23. That's the package, the size of the transistor. Oh, and it's brought some similar things as soon as I highlighted that anyway, okay? So SOT23 is the package size. If you know the package size, it's always worth putting it on the search. It will help, I would think. And we can see SMD code 6C. It probably is the one. NPN transistor. BC817-40. You can see, look, 6C in various different packages, and that's ours. Okay, that's a regulator, that one. We know it's not a regulator, we know it's a transistor, and that's an NPN transistor. Okay, so that's probably what this is. That's as likely as close as you're going to find. We can see it's a general purpose NPN transistor. We can just check to make sure ours is NPN. I think that's where I was measuring. And this is, what's the rating for this? 500 milliamps at 45 volts. So if I've got a suitable transistor to fit in here, hopefully that will just fix this. Okay, so if it is NPN, if I put the positive onto the base, which will be here, we should see the diode junction. Yes. Yes, so it is NPN. That much is true. So I think we can say fairly confidently we know what that actually is. How much space is in this thing? I'm just thinking now, if there's enough space, I can probably fit a non-surface mount. Yeah, you see like this plastic thing here. So this is where the button is that presses onto there. And there's a gap. You see? We have a sort of a gap here, space. So I don't see any reason why I couldn't fit a normal NPN transistor in here if I don't have a surface mount one. I will check first. A good reason why I think this is probably not damaged the controller is because you can clearly see the base is driven through this resistor. This is 362. That's 36 and 2 zeros, or 3600, 3.6K, another 3.6K on that one, and that goes to the controller. So if this is short, which it is, base to emitter, the controller still effectively sees 3.6k to ground, so it's not like you're shorting this to ground, so chances are there's no damage to the controller. Let's see if we can find something suitable to fit here. To save hunting around for an SMD transistor that will handle 500 milliamps, I think I'm going to use one of these. So these are just through-hole ones, BC337, NPN, 45 volts, 50 volts, yeah, fine. 800 milliamps, it's fine, I think. So let's give it a go. I should just check the power total compared with the other one though. Shouldn't be difficult, this. Just get a bit of leaded solder. I'll put a bit of flux as well, actually, that will help. Okay, just getting my chunky soldering iron tip. This helps to get a lot of heat in so it unsolders easily. That's the idea. Now, I should be able to unsolder this from one side with a bit of luck. Let's have a go. Just get some heating from this end onto the transistor itself. Because I don't care about the transistor, it's dead anyway. Let's just get around the heat. Try not to remove that resistor. Being a bit tricky actually, this one. I thought it would come easier than that. We could use hot air, of course. But I would have thought this would come off pretty well with just a soldering iron. Yeah. Took a bit of the pad of the rubbishy PCB off, but I shouldn't make that excuse because it was obviously my bad technique, yeah. Basically. But we're soldering our through-hole on, so it shouldn't matter. Oh no, it didn't take it off. It just literally actually just removed the solder. Okay, let's see. So, emitter base collector. Base is the middle pin. See if this will work. So, from the flat side, flat side this way, this is the emitter. This is the collector. That's what I want to go elsewhere, okay. So, this I want to solder on like so, emitter base, and then bring the other pin round for the collector. See if we can do that. Let's try it. Okay, you can see what I have in mind, yeah? Something like that. Yeah. Let's have a look. Yeah, let's try it. The collector can actually go somewhere up here. That's fine actually. Doesn't need to go underneath the transistor as such. Okay. Can go there. Push it back. Okay. Right. Yeah. Yeah. Then emitter base. Now, the emitter base, if you look at it, the base goes to one end of this resistor here. The emitter, well, the emitter goes to ground actually, which I think is there. Let's soon test that. In which case I should put this on the other way. No, it's the right way. Okay, so let's see. Emitter also goes to the same point as that emitter does. Okay, this makes a bit of sense. And base can go to the end of this resistor, yeah? You see where I'm going to go with this? Okay. Right. little bit shorter than that. Okay. A little bit stiffer than you might think, actually, but okay, almost. That should do it. Okay. Paste, I think I have that. I think I do have that. Let's have a look. Yeah, not brilliant though. Let's put a bit of extra solder on that. I should do this with the microscope. I'm actually just watching the screen. I'm far better with my optical microscope, but never mind. Yeah, sure that's got that now. Messy, but it's got it. And then the emitter goes to the same as that emitter, which comes up here to the negative end of this capacitor. So this can go somewhere over this way. Just scratch away a little bit at the track. Yeah. Yeah. Okay. Call that a botched job if you like, but let's see if it works first before you give me your judgment on that one, yeah? Switch it off. We'll do it this way. Okay. Balancers on top of here. Okay, so that should be fine. Okay, could be interesting. Let's see what happens. Yeah, look, blue and white. Yeah, blue and white all lit up. So there's the repair. All we need to do now is just make sure the capacitors are discharged, put this back together, and we have it working. I'm not worried much about the power dissipation on the transistor, by the way, because A, it's larger, but B, this is a pulse width modulator, so basically the transistor is either on or off. When the transistor is fully on, there's almost no voltage drop across the transistor itself. So watts, which is voltage times current, is very low because the voltage drop is very low. When the transistor is fully off, there's no current flowing, so the wattage is zero. Yeah, so basically with a switching transistor like this, there's very little wattage. Just check for any high voltages. Here's the capacitor. 14 volts. I think it's here actually. Yeah, 14 volts. So there's no dangerous voltage in this. Okay, so that's back together. It clipped together very well actually. A bit of araldite in there will seal it up, and then just a bit of tape around it if you want to, just to cover over. But I mean, it is clipped on very firmly now actually, that is. So we'll just see if this is actually still operating. Just, let's see. So here's my lights. Yeah, blue and white all operating. So that's fine. Yeah, that's good. Hope you enjoyed that. Hope you liked it. I don't know, would you call that basically a botch job? Or would you call that thinking outside of the box, yeah? Because I got the thing working, it's all back together, not in its original condition, but I'm sure it'll work just as well as the original condition did, yeah? Be very interested to hear your thoughts on that sort of repair. So let's hear from you in the comments below, yeah? I'll wish you now an early Merry Christmas, but you'll get a few more out of me before the big day, and I can go and put some more lights on the outside of our house. Ciao for now, guys.